here's what you and your partner are tasked with. And we almost did most of this for the warm-up. Here is your data set. This is the original data set that you're going to use. I'm a little worried. I got people looking at screens right now and stabbing people with pencils. This is your data set. Then, so you're going to use Desmos. You're going to find the mean, the median, and you're going to explain what your data looks like in a dot plot. So, the shape of its distribution. Then, for number 3, this is where the real work's happening. You're going to always have your original data set, and then you're going to change the numbers as A, B, C, and D are asking you to change the numbers. And you're going to check your median and your mean versus your original median mean. So, for example, for A, you're going to add 2 numbers that are greater than 14, and you're going to see what it does to your mean and median. You're just going to document that in your math notebook. For B, you're going to add 2 numbers that are less than 6 and explain how that, what that does to your median and mean. Now, notice it keeps saying the original set. The original set is where? Right there. So, after you've done A, you're going to take those values back off. You're going to add the B to the original set, not to the new set that you got when you added stuff to it. All right? So with your partner, I'm eyeing like 8 minutes for this. I think we can get her done in about 8 minutes. I want your attention up at the board. So the first thing it asked was, with this set of numbers, remember I just pulled that from right here. With this set of numbers, what is the average and the median? So I'm going to type in mean. Gives me an average of 10. In my median, gives me a median of 10. It also asks for the data distribution shape. So I'm going to look at a dot plot. And that is a symmetrical bell shape. We go with that? Everybody good?
Yep.
Okay, so next it said, we're going to add some numbers to our set and we're going to see what happens. The first thing it says is add 2 numbers that are larger than 14, right? So I'm going to pick 20 and 25. So who can explain what happened to my dot plot now?
Skewed right.
Skewed right. Now let's check out my mean and median. Instead of 10 and 10, my mean is now
11.
higher. What happened to my median though?
Stayed the same.
It stayed the same. So what I want you to ask yourself, just internally right now, which one seems like the better measure of middle at this point? 10 or 11.25? Before we had a bell shape, now we're skewed. Okay? So I'm going to take those off now. Next it said 2 numbers that are less than 6. So I'm going to go over here on my list. And I'm going to do 0 and 1. Okay, who can explain what my shape is now? Right. Skewed left. Let's check out my average. My average is now less than 10. And my median is still 10. So you need to ask yourself, what's going to be the better measure of middle, my median, or my average, knowing that I have these 2 little numbers pulling my average down. Next, it asked to add 1 above and 1 below. So I'm going to get rid of these. Below 6, let's add, just for fun, a 3. And above, we'll add a 16. Okay. Who can explain our shape now? 1 above, 1 below.
Symmetrical.
It looks symmetrical and bell shape, right? And check out my averages. My average is now 9.95, really close. What's the reason it's not 10 though? I added 1 above and 1 below. Why is my average not 10? Which one must be further away from the middle, my high or low one?
Low.
My low one. My high one's 2 away. My low one
3 away.
is 3 away. So, but in general, they're both about the same number. They're both good. Lastly, it asks us to add 50 and 100. Is that right? I'm trying to go from memory so I don't have to go back. So we'll take care of that. And get rid of this. And so make a guess what the 50 and 100 is going to do if you didn't get there. I'm going to add 50 and 100. Our average was 10. Our median was 10. 50, 100. What happened to my average? Yeah, and it went up because I added numbers that were much bigger. That pulled my whole average. It skewed it way right. Some people might say it's pretty skewed up. Yeah. I said that. So, in this case, what's the better measure of center? What's the better measure of center? Median or mean? Median. So, we can summarize this with all of them that we just looked at. If I had that nice symmetrical bell-shaped, did it matter which one I used to describe middle? Did it matter? When it was symmetrical and bell-shaped, it was just 10 and 10, right in the middle, right? As soon as I skewed it up a little bit, which one was better? Median or mean? The median. It kept staying the same, right? Because it eliminated our outliers by saying this is the middle. It was still the middle, okay? So I'm going to give you a little practice with this. Let's see if I can do it from this computer. You and your partner, you're going to go through and make 4 different sets of data. Your sets need at least 10 items in them, and you need at least 3 different numbers. So, for example, for number 1, if you need a mean and median and 10, you just can't have 10, 10, 10, 10, 10, 10, 10, 10, 10, 10. That would have a mean and a median of 10. But you have to have at least 3 different numbers in your set. So, at least 10 numbers in your set, at least 3 values that are different, and you need to hit these criteria. You need a mean of 10 and a median of 10. You need a median and a mean of negative 15. So that's 2 different data sets. Third data set, a median of 2.5 and a mean that's bigger. Fourth data set, median of 5 and a mean that is less. Now, I'm going to give you some advice here. My advice is this. Which one would be easiest to start with? Using an average to get started or a median to get started? I think median. Because if you get the median, you know you already have your middle number. Right? So if you plot median down first, you already have your middle number. And then let's say you wanted to get an average of 10. So middle number has to be 10. What numbers can pair together to give you an average of 10? Just 2 numbers. 5 and 10 would be 5 and 15 would give you 10. 2 and 18. You guys seeing that? 12 and 8. 17 and 3. So then you could pair up numbers intentionally on the sides of your median to help you get that average instead of just guessing and throwing new numbers on. You could do that, but it'd be less efficient. So my advice is start with your median. So you're going to build 4 sets. Now, here's the other thing. On Desmos, here's what you probably should do. You can get your first one set up with me. Okay, let's just get it set up to go. So for Desmos, do you guys know that you could use any letter? So let's call this one B. B equals. Okay, and I know I'm going to start with my median. My median is 10. And I'm going to keep that, and I'm going to stack things on either side of 10 to try to get an average of 10. Well, to know where you're at, you can say mean 10. Or sorry, not me, B. And median B. And use that to help. Then, instead of erasing it for your next set, just call it the next letter. You can call it C. Okay, and then you could have a mean of C and a median of C. And then you'll have your lists already ready to roll. So you can keep multiple sets of data on there doing that. So again, my advice, median first. I'm going to get those 4 you need to get done up there. Let's do the first one together. We need a median of 10, which I already have, and I need an average of 10. So I'm going to do something like, I'm going to throw a few 10s on here because that's fine. I just need 3 different numbers. And then on this side, if I'm going with a 12, what will get me on the low side to get to an average of 10? 8. So we're throwing 8 on there, okay? And on the low side, let's say I throw a 6. And there's a lot of different answers for this. What would I need up here to balance that out? 14, right? Because those equal 20. 20 divided by 2 is 10. So I need some more numbers. Let's go with 18 here. What do I need to balance 18 out to keep my 10? 2, yep. And then I need at least one more. Let's go with a 20. And what would balance 20 out? Yeah, let's go 20 and 0. Oops. Or I could have added another 10. That would have worked too. So I have 11 elements, which is fine. By the way, how many different answers are there for this? Infinite. Because if I went to 500, I could go to negative something, right, to get the average of 10. So my average is 10 and my median is 10. So you're going to work on the second one, which means your median needs to be negative 15. And then you're going to stack what you need to as pairs around that to keep your median and your mean negative 15. That's what you're working on next. I'm surprised this one, oh, it's because I capitalized it. There we go. Remember, computers aren't smart. Some time management on my end here. Let's make this set. We need a median of 5, was it? Was it 5, guys? Just so I don't have to switch back. Okay, so I'm going to throw some 5s down. And if I want it to have an average that's less than 5, do I want my high numbers to be really high? No. So I'm going to put some 6s and some 7s. And let's even put a 10 on there. So if I want to pull it low, I'm going to need some small numbers. So maybe like 0, 0, 0 would work. And let's even put it on like a -2. I'm going to throw a -12 in there. Okay, so let's make sure. Mean of E, is it less than 5? Is my average less than 5? Okay, let's make sure my median is 5. So to pull it down, your box plot would need to look like this. Whoops, I meant dot plot. Okay, skewed a little bit left. See how there's this 4 pieces of data over here? And the data there's only one kind of to the right. It doesn't pull it up as much as it gets pulled down. So that's the big idea for today, friends. That's going to be our big idea. Here it is. So do this lesson summary with me, please. We've got a bell-shaped curve. What is true about the median and mean? Which one's better? When I have that symmetrical bell shape, which one's better? Doesn't matter. Samesies is the technical term. Samesies. Okay? That's the technical term.
The mean is samesies?
Samesies is the median. That's the technical term. Okay? Big picture is, if it's symmetrical bell-shaped, it doesn't matter. They both explain the middle very well. For both of these, they explain the middle of that dart hitting right up in there.
The mean is...
So, Sam, for the second one, who can explain this shape to me for the second one? Abe, you got this. What's the shape here of this second one? Explain that distribution. Skewed left, right? That's good. So that skewed left is going to change which number? The mean or the median? Lynn?
What is that you wrote right there?
This is the technical term samesies. They both work great. It's the spot that the average works great, okay? Now down here, when it's skewed left, does that change the median more or the median? The median or the mean more? Mean, right? Remember we worked on pulling those averages up and down with the outliers? This pulls my average down, but my middle number is still going to be up in there for median. So if we have skewed data, if our data is a little skewed up, we're going to want to use the median. Because the median doesn't get pulled the same way as the average. Right? We were really messing with the average when we were adding numbers and taking away. The median on that first problem stayed 10 every time. Okay? That's the big idea from today, the effect of extremes. They pull on the average, but the median that doesn't get pulled the same way. Because it's the middle number of the data, not the redistribution of data. Excellent.